All right, so here we want to sketch the graph of x squared, x cubed, x to the fourth, and x to the fifth. So these are all what we call, just power functions. Um, for example, we could have something like this, right? Just f of x equal to x squared. What is this guy? Okay. So this one we should be pretty familiar with, right? This is just our basic quadratic equations, our u shape. I mean, we could make a table. Okay, so let's do that underneath here. Let's pick a couple values. When x is 0, y is 0, of course. When x is 1, y is 1. When x is 2, y is 4. Right? However, when x is negative 1, y is positive 1. When x is negative 2, right, for y, we're going to get a positive 4 here, right? So this is what we call our basic parabola or our U shape. So we should get something that looks a little bit like this, okay? Goes through these 5 points that I've picked over here, right? And this is x squared, all right? But now what we want to do is we want to look at, okay, what about x cubed? Okay, what about x cubed, and how does that look compared to x squared, okay? All right, let's, we'll do the same thing. We'll make a table here, okay? So we got x, we got y. And now, of course, when x is 0, right? Okay, when x is 0, x cubed is just 0 as well. What about when x is 1? Right, when x is 1, 1 to the third power is 1. When x is 2, 2 to the third power is 2 times 2 times 2, which is 8. Okay? When x is 3, this is 27, right? So we can see that for every x value here, right, the y values keep getting higher and higher, right? But here's the key though, right? What happens when x is negative? Right? When x is negative 1, y is negative 1 to the third power, which is also negative 1. But check out what happens when x is negative 2. Right? What is negative 2 to the third power? It's negative 2 times negative 2 times negative 2, which is negative 8. Okay? So the graph then, now this is not drawn exactly to scale here, okay? But the thing is, because it's an odd power, right? One thing we should notice here is that it's not going to be a U shape, okay? We're going to get a shape that looks a little something like this. It says, you can call it an S shape, okay? But we see here that it's not a U, okay? And why is that, right? If it was a U shape, then here, when x is negative, the y values would be positive, right? This is quadrant 2, right? X is negative, y is positive. But notice, look at the points that we picked, right? For every x value that we pick, the y values are negative. So this is going to be the general shape of any odd polynomial, okay? Now, hopefully we realize there's probably going to be some type of pattern here, right? So what do you think is going to happen to x to the fourth power, right? That's the leading power is even, okay? So I'm not going to pick any points here, but what we should notice is we're going to get a graph that looks a little something like this. It's going to be a little bit more flattened out, okay? But we're still going to have a U shape here, okay? And then similarly, what about x to the fifth power? So what do you think is going to happen to x to the fifth power? Well, it's an odd function, so it should look a little something like this, right? So when we say it should look similar, right? What we mean is it's not going to be a U shape, right? We're going to have this so-called S shape, right? So I want to go down to the left, and then we're going to go up and to the right. Okay? Now, once again, these are not drawn exactly to scale, but the whole point here is that you know generally what the shape of the graph is going to look like, right? So if the leading term is even, okay, now it doesn't matter what the terms are after it, right? But as long as the leading term is even, we should get a graph that looks like a U shape, okay? And if the leading term is odd, okay, then we should get a graph that sort of looks like an S shape.